Alright, we want to take the derivatives of some trig inverse functions. In this one we've got y equals the cosine inverse of x squared. So the first thing to do is look up your derivative for cosine inverse. It looks something like this: d over dx of the cosine inverse of x equals, well, let's change that to u for this one right here. We're going to do a u substitution anyway. U, and then it's the negative 1 over the square root of 1 minus u squared times the u prime, or the du. So let's see what we've got here. In that u position we've got x squared. So let's see here. This is going to be the chain rule. So if this is x squared, that's our u. The du, or the u prime, would be 2x. So we'll follow this rule exactly. Y prime will be negative 1 over the square root of 1 minus u was x squared. So u squared will be x to the fourth, and that'll be times 2x, the u prime. So we can simplify this down a little bit. 2x over the square root of 1 minus x to the fourth. Okay? Sorry, I forgot to carry that negative down that was up here. Alright, let's go to our next problem. Alright, our next derivative will be y equals the secant inverse of 2s plus 1. So first of all, our derivative for a secant inverse, you might have to look it up somewhere, secant inverse of u, is negative 1 over the absolute value of u times the square root of u squared minus 1, and then at the end of that there'll be a u prime or a du for the chain rule. So let's see what we've got here. In our problem we've got u is equal to 2s plus 1, so the u prime would be 2. So we'll just fill that in accordingly on the right hand side over here. So our derivative, y prime, will be negative 1 on top, absolute value of 2s plus 1, and keep in mind, while that seems like it's positive, it kind of depends on what the value of s is, and then that'll be times 2s plus 1 squared minus 1, and then at the end of that it'll be times 2 from the u prime. So there's the u prime at the end of it, that you might be wondering where that 2 comes from. Okay, we can clean it up a little bit, but I don't really see much use in doing too much more with it. Alright, the next one is y equals the secant inverse of 1 over t. So this is the same formula we used a moment ago. I'm going to rewrite this a little bit though. I'm going to identify my u, which my u here is 1 over t. So wherever I see u, that's what's going to happen. But what we got here, that u is 1 over t. I'm going to write that as t to the negative 1 because I want to take the derivative of it. The u prime would be negative t to the negative 2, which begs you to possibly make some adjustments to it along the way. But I'm just going to leave it as it is. I don't see much reason in cleaning these things up later on. So my derivative y prime will be negative with a 1 on top, absolute value of 1 over t if you like, times square root of 1 over t, and that will be squared, minus 1, and then out to the side times negative t to the negative 2. So in all that, we could definitely make some changes. I think if we wanted to clean it up, we could say y prime equals negative times negative will give me a positive. So let's see, how does this this t to the negative 2 interact with this thing on the bottom? Well, I think it in the end just makes it 1 over the absolute value of t, if I'm not mistaken, because there'll be a t squared out here, and there'll be a t under that. So let's clean that up a little bit since it got a little messy. So t, and then it'll be times the square root of this 1 over t squared minus 1. Okay, not the most beautiful thing, but it's working so far. Y equals s times the square root of 1 minus s squared, and then after that we're adding on the cosine inverse of s. So in actuality, this one is not so hard with the trig inverse function, but if we look at it, we're going to rewrite it as s times the quantity 1 minus s squared to the 1/2 plus the cosine inverse of s. So the main thing here is, even though we may not have done it in the last couple of minutes, there's a product rule in this first thing, a product rule and a chain rule. So let's first of all look at this thing out front and say we're going to do a product rule. So in that case, the u will be s, the v will be 1 minus s squared to the 1/2. So u prime will be 1. V prime will require a chain rule. So 1/2 out front times 1 minus s squared to the negative 1/2. That's the power rule part of it. And then the chain rule says, oh, here's an extra u in here. Let's put a u prime on the outside. So you'll have a negative 2s on the outside. So a few things will clean up there as far as, first of all, the 1/2 and the 2 will go away. But I don't know what else we'll do with that. So let's just kind of finish that part up. Let's put our product rule back together. I doubt we'll clean this up. So product rule, v. So 1 minus s squared to the 1/2 times u prime, which is just 1. You hate to write it, but there it is, plus u, which is s, times v prime, which is 1 minus s squared to the negative 1/2 times s. It is kind of begging us to clean that up. I will write it again. Let's just write it down here in the bottom. Y prime equals the square root of 1 minus s squared plus s squared over the square root of 1 minus s squared. Now it's begging me to rationalize this second one or do a common denominator. I'm not going to fall for that trap. I'm tired of working with that stuff. So then over here we've got the cosine inverse part. So our derivative for the cosine inverse is, we're just going to bring this on down, negative 1 over the square root of 1 minus, in this case, s squared. So we'll pull that all the way down here. So minus 1 over the square root of 1 minus s squared. So they are really begging us to make a common denominator and combine things here. I think I'm going to fall into their trap. I got a couple minutes here. So let's make a common denominator. Y prime equals, if I make square root of 1 minus s squared on the bottom of all these, it'll be 1 minus s squared over the square root of 1 minus s squared. And these two over here already have a common denominator, so I'll go ahead and combine them. S squared minus 1 over the square root of 1 minus s squared. Common denominator, 1 minus 1 goes away, negative s squared plus s squared. It looks like the derivative of this thing is 0. What does that mean? Slope 0. That's a flat line. That's even more intriguing if we go back and look at it. So maybe I'll do that independently, but let me check on a few things before I close out. Alright, so good learning opportunity here. I fell into a trap. I'm backing up the page a little bit here. So hopefully you saw this and wondered what in the world was going on, but there was a negative here in the v prime, and I just lost that little guy. So let's just knock this thing here out and put a negative in front of it. And that really does change the answer, because now I'm going to have negatives in other places. And let's see if this makes a big difference. That would have made me stop a lot earlier, but I thought something great was happening. So in that case, when I make the common denominator, there would be a negative right here. So it doesn't zero out. Let's just knock this out. It looks like the ones go away, but it looks like I would have negative 2s squared over square root of 1 minus s squared. So sorry about the little side journey here, but it looked like I was doing the right thing. We all live and learn. Thanks.